I'm Robert Gagne. As instructional design moves out of its infancy, it is important for instructional designers to be aware of the tools which may assist them in their planning. Accurate planning can support the achievement of learner outcomes. One type of learning outcome is intellectual skills. Today, we intend to look at intellectual skills and ways of analyzing them by means of learning hierarchies. This kind of analysis is done to reveal the simpler skills of which they are composed. In other words, their prerequisite skills. But first, let me set the stage by the question, how many different types of learning outcomes are there?
Instruction may be designed to support 5 major kinds of learning outcomes. These learning outcomes are cognitive strategies, information, motor skills, attitudes, and intellectual skills. Learning hierarchies are applicable to intellectual skills, and, in their strictly defined form, they are not applicable to other kinds of learned capabilities. They apply to intellectual skills, the learning of rules, concepts, and discriminations. When a new rule is learned, that is, the kind of capability which makes possible rule-governed performance, the learning is a matter of combining simpler rules or concepts into a more complex whole. This means that the new skill to be learned has some prerequisites. These prerequisites are subordinate skills or rules that are actually incorporated into the newly learned, more complex rule. As a very simple example, take for instance the skill of adding 2-place numbers. As learned by a young child, this skill incorporates 2 prerequisites. One is adding 1-place numbers. The other is the operation of carrying or regrouping. When the new skill is learned, it actually incorporates these 2 prerequisite skills. You have already been informed that a learning hierarchy has something to do with prerequisite skills, with subordinate intellectual skills that become an integral part of a newly learned, more complex skill. The prerequisites of any and every intellectual skill can be determined by analyzing the skill. Just think for a moment of how that can be done. If the question is asked, what must the learner know how to do in order to learn a new skill which is a combination of these prerequisites? For the example we have used, you would surely be able to answer adding 2-place numbers. You would say, if this more complex skill is to be learned, the learner must be able to put together some simpler skills, follow some simpler rules, namely, adding single-place numbers, identifying numbers with 2 places, and carrying. The process of analysis is carried out by asking the following question with reference to any new intellectual skill to be learned. What is it that the learner has to know how to do in order to learn the new skill? Strictly speaking, the question is asked in the negative. What subordinate skills must the learner already have, the absence of which would make it impossible for him to learn the new skill? By asking this question, one can identify the prerequisites of an intellectual skill. In a theoretical sense, the learning of a new skill is a matter of combining simpler skills which have been previously learned and are accessible in the learner's memory. Notice that these subordinate skills may have been learned a long time ago, or they may have been learned just minutes ago. But they must be present in the learner's working memory at the time the new learning occurs. Now, if one applies this analysis to a somewhat more complex skill, some interesting things can be noted. One example the same way. Each of these is also found to be composed of simpler skills, rules, or concepts. So, if the process is continued, the result is a diagram which shows not only the prerequisite of the original skill to be learned, but also the prerequisites of these prerequisite skills. The result is a learning hierarchy. As shown in the example, the target skill to be learned is subtracting whole numbers of any size. A first analysis of this skill shows that it requires 3 sub-skills having to do with borrowing. Number 8 is the skill of borrowing more than once in columns that are not adjoint. Number 9 is subtracting when borrowing is required in adjacent columns. And number 10 is subtracting when double borrowing is required, as is true when a 0 is involved. At the same time, an even simpler skill is involved in this target skill, namely number 4, subtracting in successive columns when no borrowing is required. Now, these subordinate skills themselves may be analyzed into simpler skills. For example, skills 8, 9, and 10 all involve the simpler skill numbered 7, subtracting when a single borrowing is required in any column. Number 7, in turn, requires the simpler skills labeled 5 and 6, identifying the situation in which borrowing must be done, and subtracting a 1-digit number from a 2-digit number with borrowing. Thus, as the analysis is continued, the skills get simpler and simpler, and more generally applicable. We finally arrive at the skill of simple subtraction, required in all the others, and shown here as number 1, at the bottom of the hierarchy. What do the theoretical aspects of learning hierarchies amount to? Remember first that they apply only to intellectual skills, so far as is known, not to the learning of information or attitudes. The prerequisite of any new skill or rule to be learned are combined into the new skill and become a part of it. This means that provided the subordinate skills have been previously learned and are available in the learner's working memory, learning the new skill should take place very readily and rapidly. As shown in the illustration, if the prerequisite skill or skills have been mastered, learning of the new skill will be maximally facilitated. That is to say, there will be positive transfer of the prior learning to the new learning. However, if there has been no prior mastery of the subordinate skill, learning of the new skill will not be facilitated. Positive transfer will not occur. You should note that a learning hierarchy says something important about internal conditions of the learner at the time he learns a new skill. It says that certain specific prerequisite skills should be accessible to the learner's memory at the time the new learning is undertaken. It is perhaps equally important to note what the learning hierarchy does not say. It says nothing about the external conditions of learning. It doesn't tell what the instruction is like, whether it be instruction delivered by a teacher or delivered by the learner to himself as self-instruction. So it says only this: the prior learning and recall of prerequisite skills is one essential for the learning of a new intellectual skill. You are perhaps ready for the question, Of what use are learning hierarchies for instruction? Of course, they are useful for the planning of instruction. They remind us that when a new intellectual skill is to be learned, an important first step is to see whether prerequisite skills have been learned. If they have not, it will be a good idea to teach them first. If they have, students should be reminded of them and encouraged to recall them so as to be ready for the new learning. In a more comprehensive sense, one can say that learning hierarchies provide a basis for the sequencing of instruction. Observe that they do not suggest a rigid sequence, only what may be called an adaptive sequence, in which what is taught next is adapted to the pre-existing capabilities of the learners. If the learner already knows a prerequisite skill, the hierarchy doesn't suggest that he be taught that skill all over again, merely that he be reminded that he already knows it. Another point about sequence will be evident from the diagram of the hierarchy. Notice that the subordinate skill labeled Roman numeral 7 is subordinate to 8, 9, and 10, and so should be learned, or already known before 8, 9, and 10 are to be learned. But no particular sequence is suggested for 8, 9, and 10. All of them are essential, but the hierarchy does not specify which should be learned first. Another important question: can the sequence of subordinate, superordinate skills be changed in instruction? Yes, it can, but that involves some further consideration of what is really taking place. Sub-skill 7, for example, can be taught before the separate instruction of sub-skills 5 and 6. What is actually being done in that case is that the subordinate skill is being taught together with the subordinate skills, all in the same time interval. This can easily be done if the learners are sufficiently capable. The fact that sequencing of instruction can be done in this manner does not negate the basic idea of the learning hierarchy. Since the hierarchy suggests an adaptive sequence, it does not deny the fact that a bright student may skip over the learning of some of the intervening skills by learning them all together with a superordinate skill. As for the scope of applicability of learning hierarchies, we have used examples from mathematics. Mathematics is a precise and logical subject composed almost entirely of intellectual skills, so it provides examples which are easy to follow. The analysis which results in learning hierarchies, however, is perfectly possible of application to the learning of language skills, the rules of language that are employed in composing sentences and larger bodies of prose or poetry, and the rules used for reading and spelling. Learning hierarchies can be constructed to describe specific topics of science, since these too are concerned with the learning of rules and concepts. They are also possible for social studies, but one must be constantly aware that they are intended to describe intellectual skills, not information. How to construct a table comparing the exports of several countries is an intellectual skill in the social studies realm. Recounting the events of the presidential election of 1932 is not an intellectual skill and cannot be represented by a learning hierarchy. A number of examples of learning hierarchies are illustrated in the book Principles of Instructional Design by Gagne and Briggs. It is also of some interest to note that learning hierarchies are applicable to a variety of kinds of students, of various ages and various countries. Richard White, for example, has carried out some important studies of validation of the learning hierarchies in Australia. He used particularly a hierarchy of the task of learning to find the slope of curved line graphs. His colleague, Link, showed that the hierarchy White developed was equally valid in describing the learning of students in New Guinea. So a learning hierarchy, once developed in a valid form, appears to have considerable breadth of applicability. Another kind of application should perhaps be noted. Although we have tried here to stick to the strict definition of learning hierarchies as applicable only to intellectual skills, other people have advocated the liberalizing of the idea and its application to other domains of learning. For example, a book by Cook and Walbesser entitled How to Meet Accountability describes learning hierarchies for mathematical topics, but also other kinds of hierarchies called topical hierarchies, which they apply to the learning of literature and social science. In other words, Cook and Walbesser are suggesting that the notion of hierarchy is broadly useful for the planning of instruction and the sequencing of instruction. When used in this sense, it would be preferred to call the hierarchies they construct instructional maps. An instructional map is a diagram that shows the teacher what students should have learned and what they have yet to learn. If they are indeed as useful as Cook and Walbesser maintain, we can scarcely object to them. But it is of some importance to emphasize the precise meaning of learning hierarchies, as it is to describe various kinds of intellectual skills.
Remember that learning hierarchies attempt to describe the internal conditions for learning intellectual skills. They do not describe the external conditions, the instruction itself, nor are they applicable to the analysis of verbal information or attitudes, only to intellectual skills, such as the example we saw of subtracting. What part do learning hierarchies play in the design of instruction? Keep in mind that learning hierarchies are an adaptive sequence to conform to the variables of the specific situation as well as to the capabilities of the learner. Learning hierarchies allow the designer a basis for sequencing instruction to obtain an intellectual skill. Correct use of learning hierarchies will allow you, the designer, accurate and effective planning in the sequencing of such instruction.
Preceding was an instructional media production of the Instructional Systems Development Center, Florida State University.